All right, so this is triangle congruence worksheet explanations, okay? That's what we're talking about today. Now, the worksheet you guys had given to you guys yesterday, all right, which was this one, okay? It'll be on Schoology. All right, we're going to talk about every single one of these, and we're going to annotate a little bit on around them. I recommend having your notes out because writing down these in your notes will also be very helpful. If you want to just use a worksheet, that's perfectly fine. But I'm going to be making some very important notes along with this that'll be very helpful, especially for your next test. To start off, the camera's a little wonky right now. Hold on. Whoops. I forgot that it can do that. All right. So for number 2, okay, we have, as you can see in the worksheet, we had 2 triangles that are connected to each other along one side. Okay? All right. Connect the 2 together. There we go. We'll call this S, R, and T, and Q. All right. We know this angle is congruent to this angle, and these angles are congruent to these angles. Okay? Now, for triangles RST and triangle TQR, remember, in order for triangles to be congruent, you must have 3 parts. Okay? Referring to specifically 3 parts of congruency. One set of angles, another set of angles, another set of side, or 3 sides, or any of the ones we discussed about in the notes in 2.4, or at the beginning of 2.4, in that little packet. Now, if we make the observation that SRT is sharing inside these triangles, ladies and gentlemen, something I want you to write, put a star and write this, is this. Things are, bless you, congruent to themselves. Okay? Things are congruent to themselves. That means that RT is congruent to RT. And we're going to put what I like to call stitching on it. Which signifies a congruency of 2 things or the same thing. Okay? So your answer for the first one is angle side angle, because RT is congruent to RT since things are congruent to themselves. And that's it for that first one. Okay? I'm just going to move this up to, does everybody have up to that point right there, or do we need to move back up a little bit? That good? Okay. All right, so that's the first one. Number 3, okay, we have 2 triangles. Like so. which is J, K, L, N, and M. Okay. JKL is there, and NML is congruent here. We are also told that JK is congruent to MN. Sorry. Okay. So let's go ahead and write down what we know. We know that KJ is congruent to MN. We know that angle JKL is congruent to angle LMN. And remember, the vertice of the angle is always in the middle. Now, in terms of the rest of this triangle, these two triangles, well, let's think about this for a second, okay? We know that things can be congruent themselves. There's also another one where we can recall that if I have two transversal lines that cross over each other, what is the sum of all these angles right here? These two angles right here. 180, right. Okay. So that means, let's just call this angle right here 60 degrees. Sorry, it's on top of the thing back there. So I'm getting a little bump. Okay. Now, that's 60 degrees. What's this angle right here? 60 degrees as well. Okay. It is congruent. So does that mean that angle KLJ is congruent to MLN? Yes. By the vertical angle theorem. So our answer would be, well, actually, first after stating that angle KLJ is congruent to angle MLN, vertical angles. Okay. And our answer would be angle, side, because angle KLJ is congruent to angle MLN by vertical angles. All right. I'm assuming everybody's up to that point. Is everybody up to at least that point right now? At least the bottom of three, top of three there? Or do I need to move it back up a little bit? It's okay, you can tell me. Actually, just in case, because I don't need that much space. We'll go right there. Okay? Now, number 4. Yeah, right here. Number 4, we have two triangles that look oddly like what on the worksheet here? Let's take a look. Look at number 4. What do they look like almost? Right angles. Okay, so let me draw these out first, but then I'm going to ask a quick question as to regards to that. Okay, so I've got two triangles here. This one's D, E, F, and this one is J, H, G. Okay? And we're told that this angle is congruent to this angle, and this angle is congruent to this angle. Now, something to keep in mind. Unless it tells you it is a right angle with the little box, you cannot assume it's a right angle, even if those two angles that look like right angles are congruent. So first, you cannot assume it's a right triangle unless shown, little corner with a box, right? Let you see that. Secondly, there are only two parts here. Okay? Now, what we're missing is the stitch. The stitch being on either one of two pairings. Option 1 is EF and GH, and option 2 would have been ED and JH. Those were our two options. If they had supplied to that, we could have then said that it could have been angle, angle, side, or angle, side, angle. But since they didn't, it fails. Right? So the answer to this one is the triangles are not congruent. Does everybody have up to that point? Yes? Okay. Thank you.
It says and J what?
And JH. That's segment JH, so right here. Okay? Now, on the bottom, on the top subject of right angles, I want you to make a note. Okay? Note. If a right angle is between the two congruent corresponding sides, it is SAS, side angle side, congruency. If the right angle is not included, it is hypotenuse leg congruency. Okay? Now, what I mean by that is this. Visually, this is what's going on. If I have two right triangles, okay? It's this versus this. Something one of my other students pointed out in first block was you could also word it in a very more direct and simplified manner with only concern to one specific aspect. And that was that the stitch is on the hypotenuse and there is a right angle. It is hypotenuse leg.